So the final function, inverse function for the day that we're going to look at is the inverse tangent function. Now remember, in this class, we're only going to look at three inverse functions. That's the inverse sine, inverse cosine, which we already looked at, and then inverse tangent. Okay. So again, if you recall the graph of tangent, the graph of tangent sort of goes like this, right? You have the y-axis. Say this is pi over 2, pi, 3 pi over 2, and then I have 0, negative pi over 2, negative pi, negative 3 pi over 2. Okay, and then if you recall, at every odd multiple of pi over 2, so pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2, we had vertical tangent lines, right? And your function went something like that. Okay. So again, if you see, this is not a one-to-one function because I could draw any horizontal. In fact, take the x-axis, right? It's a horizontal line that cuts through my function in more than one point. So this is not going to work. So again, I'm going to go ahead and restrict my domain. And if you look here around 0, if I crop this, right, and erase everything else, then this window here, okay, that gives me a perfectly one-to-one function which takes all possible values that tangent can assume. Okay, so let's go ahead and zoom in over here, and my function, okay, so let's say this is negative pi over 2, and say this is pi over 2. So I have my vertical asymptotes here, okay. All right, this is my point 0, and so my function now looks something like that. Okay, and that's one cycle of my tan function, right? It's also one-to-one. So what I'm going to do here, like I said, I'm going to restrict my domain to negative pi over 2 less than x less than pi over 2. The reason I don't include negative pi over 2 and pi over 2 in my domain is because at that value the function isn't defined, and so, right, it's going to be everything between them. So it's pretty similar to, if you remember, for inverse sine function, we had negative pi over 2 less or equal to x less or equal to pi over 2. The only difference here is that I don't include the endpoints. So now I want to find the inverse of this function. What I'm going to do is draw my line y equal to x and then reflect it, right? So what happens when I reflect this function? So first of all, if you remember from our talk of inverse functions, if something had a vertical asymptote, now it's going to have a horizontal asymptote, right? Think in terms of ln x and e to the x. E to the x had a horizontal asymptote, and when I found its inverse, which was ln x, it had a vertical asymptote. Well, the same is going to happen here. Is my vertical asymptotes at pi over 2 and negative pi over 2, if I reflect them over the line y equal to x, so let's say this is my line y equal to x. Okay, if I reflect it about that line, they're going to become now horizontal asymptotes at pi over 2 and negative pi over 2, right? So I'm going to have horizontal asymptotes over here and over here. Okay, and now my function is going to go this way. Okay, so this pink curve here, that is the graph of the inverse function of tangent, the inverse tangent function. Okay, so before we go ahead and take a look at this in Desmos, let's go ahead and formally define what this function is. So we write the inverse, or rather we denote the inverse of the tangent function as y equals arc tan x, or y equals tan inverse x. Again, not to be confused with cotangent. This is not cotangent x, okay? This is not 1 over tan x, all right? And we say that y equals tan inverse of x, right, if and only if tan of y equals x, okay, where negative infinity less than x less than infinity, okay, and negative pi over 2 less than y less than pi over 2. So let's take a look at this on Desmos. Okay, so here is your graph of the tan function, right? Here, if I zoom out, you can see that obviously this is not a one-to-one function. And what I'm going to do here is I'm going to go ahead and restrict my function, right, to negative pi over 2 to pi over 2. So now we can see, even if you zoom out, we can see that that's a one-to-one function, okay? Now, as we saw in our graph up there on the board, I have vertical asymptotes at negative pi over 2 and pi over 2, right? So here are my vertical asymptotes. Now, what happens if I go ahead and graph the inverse? So first thing, when I graph the inverse, I'm going to get this function over here, right, that red line over there, and it's going to give me horizontal asymptotes at pi over 2 and negative pi over 2, right? So let me just go ahead and quickly hide the original function. And so this is the graph of y equals arc tan x or tan inverse of x, right? And this is the graph of tan x in its restricted domain. So let's take an example here. We want to find the exact value of y here. In the first case, y equals tan inverse of 0. Now, according to a definition of tan inverse or the inverse tangent function, we know that y equals tan inverse of 0 if and only if tan of y equals 0. Okay, so basically what we want is we want an angle such that tan of that angle is going to be 0. Okay, and we know such an angle, and that angle is going to be 0. We know that tan of 0 is equal to 0. Okay, and so then we can say that since tan of 0 equal to 0, that implies that tan inverse of 0 equals 0. So for the first one, y is going to be 0. Okay, let's look at the second one. What does that mean? Y equals tan inverse of negative 3. That means that tan of y equals negative root 3. Now, right, what is the domain of my tan inverse function? For my tan inverse function, I restrict my tan from negative pi over 2 to pi over 2. Right, so I'm sort of restricted to the first and the fourth quadrant in a sense. So in the first quadrant, tan is positive. So obviously this y cannot be in the first quadrant because I have a negative root 3. That means it needs to be down here, the second quadrant. So think about what angle in the fourth quadrant gives me tan of y equal to negative root 3, and that angle is going to be negative pi over 3. Okay, and that falls in the fourth quadrant. Remember that if the sign is negative, I'm not going counterclockwise, I'm actually going clockwise, right? So it falls in the fourth quadrant. So I know that tan of negative pi over 3 is negative root 3. Okay, also note that negative pi over 2 is less than negative pi over 3 is less than pi over 2, right? So that angle negative pi over 3 falls in the domain, restricted domain for my tan, or in the range of my tan inverse. Okay, and so then I have tan of negative pi over 3 equals negative root 3, which implies that tan inverse of negative root 3 equals negative pi over 3.